this is a perfect topic for today. Welcome to Saskatchewan Mining Week, our webinar with the Association of Professional Engineers and Geoscientists, Saskatchewan Geological Society, and Saskatchewan Geological Survey. As we test out GeoExplore Saskatchewan, the fantastic new website we have for leveraging GIS tools so that people can explore geoscience features as they travel around the province virtually or in person. My name is Pam Schwan and I'm president of the Saskatchewan Mining Association. I'm going to ask everyone that still has their video cameras on just to shut them off because we've got close to 135 people on the call and we want to make sure we've got the right bandwidth. So if you can please turn your video cameras off, that would be great. Just a little bit of background on GeoExplore Saskatchewan. It was developed in partnership by the Saskatchewan Geological Society as well as the Association of Professional Engineers and Geoscientists with support from other agencies, including the Saskatchewan Geological Survey, the Royal Saskatchewan Museum, the U of S, U of R, and the Saskatchewan Mining Association. It is the Saskatchewan Geological Highway Map gone digital. We are really excited about its use by educators as there are many great correlations with grades 4, 7, as well as energy in mines 10, 20, and 30. It's very hands-on and can be integrated into other subject areas as well. Plus, it is free and accessible. I'd like to welcome the chairs of GeoExplore Saskatchewan project and other key contributors who will be facilitating today's presentation, including Kate McLaughlin, co-chair of GeoExplore Saskatchewan project, Saskatchewan Geological Society, and director of academic review for APEGS, Ralph Maxleiner, co-chair of the GeoExplore Saskatchewan project and a Precambrian research geologist with the Saskatchewan Geological Survey, Samantha Vander Kerkhoff, Precambrian research geologist with the Saskatchewan Geological Survey, and Savieta Ma, Precambrian research geologist with the Saskatchewan Geological Survey, Energy and Resources. So I'd like to welcome our partners in hosting this webinar, APEGS, the Saskatchewan Geological Society members, Geological Survey, and many of our own members, including those on our outreach Ed Outreach Committee. We have about 135 people on the webinar, so thank you for joining us this afternoon. Before I turn the microphone over to Kate to more fully introduce GeoExplore, I'd like to go over some virtual housekeeping items. Everyone's microphone has been automatically muted to keep background noises to a minimum. We would also ask that you turn your video camera functions off so our presenters are featured. We welcome questions, but please use the chat function on your team toolbar and not the hands up sign. Ralph will facilitate the Q&A as we move towards the end of the presentations, I believe. Also, we want to let you know that we are we are recording this virtual launch. So with that done now, it's really my pleasure to introduce Kate McLaughlin to you, co-chair of the GeoExplore Saskatchewan project. Kate?
Thank you very much, Pam. It's wonderful to see so much interest today in this presentation. I hope you're really going to enjoy it. So let me just share my screen here. And one question that I'm thinking people are going to ask is how do we find it? So unfortunately, the official name of the website is not GeoExplore, but it's easy to find if you just type it into your browser. And it's actually going to take you to the Saskatchewan Geological Society website. And if you click on the picture of GeoExplore Saskatchewan, that'll take you right to it. But before we do that, I wanted to just highlight a couple of things here about the Saskatchewan Geological Society. So we have a variety of different categories of membership. So we have individual membership and corporate membership. So if you're not already a member and you'd like to be, you can sign up online through our website. We also have individual membership for people that are not geoscientists. So we have that too. So if you're just interested in geology and you think it's cool, we'd love to have you join the society. So one other thing I'd like to point out, which we haven't quite got incorporated into the website yet, and that is our lesson plans. So we have a bunch of lesson plans available already that you can find links to. I know we have some educators on the presentation today, so you can click on these links to see the lesson plans that we have so far, and we will be adding some more. So now back to GeoExplore. So when you first get onto the web page, there's an introductory page here that tells you a little bit about it. But what I want to take you to quickly is the extras tab. So we have a page there called About Us, and we also have one here for teachers and field trips. So this is where the lesson plans will go eventually. And if you just scan down through here, it tells you a little bit about where this idea for this website came from. And like Pam mentioned, we decided it was time for a refresh on the geological highway map of Saskatchewan, which many of you may be familiar with. And we thought in this era, it really should be a digital version that we went for. So we looked around for how would be the best way to do this and decided that the Esri platform story map would be a great way to present this. So it's a platform that they have that's set up specifically for linking stories and visuals to spatial data to maps. And so that's the platform that we've used here. So it does have some limitations, but I think it generally works very well for this. So I'm not going to say too much more now. I'm going to hand it over to Samantha and Savieta for their presentation, and they're going to take you on a virtual tour through some of the geological highlights of the province using this new website. And then afterwards, I'll come back and take you on a little bit of a tour, a live tour through the site to show you how it works. And we'll have a chance for questions in between the various sections here as we transfer the control from back and forth between myself and the presenters. So I'm going to stop sharing my screen right now and pass it over to Sam and Savieta. And if there's any questions, we could do a couple quickly now, but probably most of the questions will come after the presentation by Sam and Savieta.
All right, thanks a lot, Kate. Just give me a few seconds here. Okay, so hopefully you are all sharing the screen with us, and thank you all for joining us as we take you on a virtual geological tour across Saskatchewan. So what we're hoping to do here is not only highlight some of the amazing information that can be found on the GeoExplore website, but also break a few stereotypes. Everyone thinks of Saskatchewan as this flat prairie landscape, something where you watch your dog run away for 5 days, or all the other jokes that you've had or heard. But we'd like to show you and highlight that Saskatchewan has a lot more to it than just the beautiful prairie flat landscapes. One of the more famous ones is Castle Butte, and most of you have probably seen this or been there. It's quite iconic and is found south of Regina, and it's actually such a beautiful landscape that we chose its outline for the GeoExplore logo. A few other amazing landforms in Saskatchewan that you might not have known about this one is Hunts Falls, and Hunts Falls is located on the Grise River in northern Saskatchewan. It's actually 60 meters wide and 15 meters tall. So that's a very significant size waterfall. And if you can see in the foreground of this photo, you actually have a helicopter and some people on a rock there. So it gives you kind of a bit of perspective for just how big this actually is. Another high topographic relief feature that you can find in Saskatchewan is called Skull Canyon. Skull Canyon is located on the Clearwater River, and it cuts through cliffs that are 25 meters high. And unfortunately, I don't have any photos with canoers in there that show just how, I guess, beautiful and steep those cliffs really are. Another pretty spectacular and picturesque feature that you can find in Saskatchewan in a couple different locations is actually amazing active sand dunes. So this one featured here is the Great Sand Hills found in southwestern Saskatchewan.
All right, so those are some highlights of what you can find in Saskatchewan. And here, or as Kay already mentioned, you can use the GeoExplore tool to discover even more sites across the province and learn some basic geological principles. And as Kate alluded to, it's a great tool for educators. So yeah, and for context, this presentation was originally put together for back in March when it was Engineering and Geoscience Week, and we were going doing these presentations for school children. So we have updated the presentation a little bit, but we've kept it playful for fun. Yeah, so don't worry about this long link. Kate will show you how to access it in a much more in an easier way. And yeah, so today we're going to take you on a virtual road trip. So we'll use the GeoExplore tool, which is essentially an interactive digital highway map. And it's something that you might want to use next time you're planning a trip and you're curious to know what's around you geologically. Okay, so this is our route map for our road trip. So we've mapped it out so from the southeast to all the way to the northwest corner of the province. So we're taking Saskatchewan highways, and then we've just designed a nice little camper van to keep track of where we are. So we'll start the road trip in Estevan. So many of you will know Estevan for its coal mining, which generates electricity for the province. Coal deposits form through the accumulation of decaying plant matter or organic matter that settle in these swampy environments, and then over time it turns into peat. So as ancient swamps get buried, the added heat and pressure converts the peat into lignite, lignite, bituminous, and anthracite coal. So the coal beds in Saskatchewan originated from the Cretaceous period at 110 million years ago, 75 million years ago, and at the Poplar River coal mine, the coal is actually from the Tertiary period at 65 million years ago. So now we mine lignite rank coal in the Estevan area, and it's used to generate electric power at the Boundary Dam Power Station. Oops. So because coal is a form of carbon, when we burn it, we release carbon dioxide into the atmosphere, and that's a potent greenhouse gas, which has a significant impact on our global climate. So in the past few decades, scientists have been developing technology to capture carbon from the atmosphere. So this carbon capture and storage, this is a graphic from Sask Power that shows how this type of technology would work. So carbon capture can either basically take carbon out of the atmosphere just like plants do, or we can actually extract carbon dioxide and sulfur dioxide from power plants. So say a coal power generation station, as we process the coal, you can take out the carbon dioxide and sulfur dioxide. And for sulfur dioxide, you can transform it into a liquid state or into solids. And this can be repurposed for the chemical industry. And then carbon dioxide can either be stored, or more commonly, it's repurposed and used for enhanced oil recovery. So that's just another way to effectively recycle carbon dioxide. So this type of innovative carbon capture technology was tested out at Boundary Dam. So in terms of other innovative energy technologies, geothermal power generation is a renewable form of energy that uses the Earth's internal heat that, of course, we know increases with depth. So if we were to drill a geothermal well we can tap into a hot aquifer and we can capture Earth's heat in the form of steam to generate electricity. So that's exactly what one company in Saskatchewan is doing. So DEEP, which stands for Deep Earth Energy Production, recently drilled the deepest well in the province. So that's a depth of over 3.5 kilometers. So DEEP uses existing drilling and power generation technologies to harness Saskatchewan's geothermal resources. So the vision here is that this geothermal project will be able to establish a long-term and renewable baseload power supply, and in doing so, build on Saskatchewan's drilling innovations and expertise.
So now we will continue our road trip towards the west, and heading that way, we will stop at a place called Avonlea Badlands. So the photo of Avonlea Badlands there is a spectacular landscape with all these cool crevices formed in the sedimentary rock. These crevices and formations are formed when water seeps into the sediments and into the ground, and the water freezes, and then as that freezes and becomes ice, the ice expands and cracks the earth apart. In spring, when the ice melts, then it helps wash away sediment and creates a fissure or crack that continues to get larger as rainwater comes down and washes away sediments, creating this landscape and ever changing and creating it deeper and more spectacular fissures into the rock. In Avonlea, not just these fissures in the cliffs are formed, but there's a landform called a hoodoo. And a hoodoo is this really neat stack-like feature. And what differs from a hoodoo compared to the rest of the landforms is that this hoodoo had, or the stack, had a cap on top of it to protect it from erosion from the top. So what happens here is you'll have softer clay stones and mudstones that make up most of the cliff, and the top cap is a more competent, stronger sandstone rock. So when rainwater comes down, the sandstone cap protects the top of the stack or the hoodoo from erosion, and the water is then able to run down the side of it and erodes the rock from the side rather than top down, and that's how you get these really cool stack-like features. As we continue to drive west, you can look out your window and potentially see a very cool, what looks like a large hill or a local elevation high or topographic high in the southwestern part of the province. One of these local highs is called Cypress Hills. And the reason for this type of landform is, as most of you know, thousands of years ago, all of Saskatchewan, or most of Saskatchewan, was covered by glaciers. So the glaciers came across the province and scoured the land clean and flat. And in the southwestern part of the province, there were areas that the glaciers missed or that they moved around for various reasons. And that's why now places like Cypress Hills are left much higher and hilly, while the flat plains are smoothed around it in the rest of the province. And nearby Cypress Hills is a town called East End. East End is particularly famous for its rich dinosaur fossils. And hitting the news in the last year or so, everyone I'm sure has heard about Scotty the T-Rex. So Scotty is pretty famous, and he's currently housed in the Royal Saskatchewan Museum. And he's so famous because it's thought to be the largest T-Rex ever found in the world. The skeleton was 65% intact. Discovered in 1991 and named Scotty after the drink Scotch that was the celebratory drink when they made this discovery. Took a long time to excavate Scotty. There was two kind of bouts of excavation, one from 1994 to 95 and again in 2000 to 2003. Researchers believe that Scotty stood about 13 meters long and weighed an estimated 19,000 pounds or 8,800 kilograms. Scotty died at about 30, which is quite old for a T-Rex, and it would have lived a pretty hard, tough life based on the many fractures and bite marks and evidence of injury on the skeleton. Another cool fact about Scotty is researchers actually believe Scotty is a female. Here's another photo of a brontothere molar that was found near East End. And if you are not a expert in dinosaur fossils like myself, I had to look up what a brontothere looked like. And this is what I found. So I guess he was kind of a rhinoceros with horns looking dinosaur. Another more famous and common dinosaur that has fossils found near East End is the Triceratops.
Okay, now as we head back east towards Moose Jaw and Regina, you're going to be gazing out across the classic prairie landscape. So whether that's meadows or farm fields under the blue skies, you suddenly start to notice this white patch that's at the side of the highway. So I guess we are actually driving past Chaplin, which is a small village that's where sodium and magnesium sulfate is harvested. So this is like a type of salt deposit, but it's different from table salt or the salt that you put on the roads in the winter. So sodium and magnesium sulfate is mined primarily to be used as a chemical in making detergents. So a lot of the household detergents like laundry and cleaners have used sodium and magnesium sulfate. So these are a type of evaporite deposit similar to salt and potash. It forms by the evaporation of brines from special types of lakes. So these are post-glacial, hypersaline, perennial lakes, groundwater fed lakes, and internally drained lakes. These lakes are all alkaline in nature. So in the summer months when it's much warmer outside, the brines become concentrated, and then with lots of wind and heat, evaporation causes these minerals to precipitate. And so this photo shows the shoreline of Lake Chaplin. You can see these rings of salt deposits. Okay, so we're going to head towards Regina, and there's another type of sedimentary deposit that we mine near Regina, and I'm sure everyone knows that this is potash. So we have a few mines near Regina and across southern Saskatchewan, and I'm sure everyone's also familiar with the fact that Saskatchewan is the world's largest producer of potash, and of course potash is used as fertilizer. Now most people should be familiar with underground potash mines like those at Esterhazy, Bethune, or Rocanville, but the Belle Plaine mine uses a different style of mining called solution mining. So instead of a conventional underground mine, solution mining will inject a heated brine solution underground to where the potash deposit, where the layer of potash is, and then it dissolves the potash and then recovers it by pumping it back up through a second well. And then the brine solution is put into designated crystallization pools or ponds. So in these ponds, they recrystallize the solution, the potash and other salts will recrystallize from the solution. So these mines essentially have the advantage of improved safety for mine workers because people aren't exposed to any to some of the hazards that might affect underground mines like tunnel collapses or fires. And sometimes for very deep deposits, solution mining is actually the most efficient way in terms of infrastructure and investment for extracting those resources compared to conventional mining operations. All right, now we're going to head north and we'll cross the Qu'Appelle Valley. So have you ever wondered how the Qu'Appelle Valley formed? So it seems like an awfully large valley for the lonely meandering Qu'Appelle River. Well, thousands of years ago, as Sam mentioned, Saskatchewan and most of Canada was covered by a large ice sheet called the Laurentide ice sheet. So when this ice sheet started to melt about 12,000 years ago, there are massive amounts of meltwater that's coming off of the retreating glacier. So this meltwater will carve various landforms. And the Qu'Appelle Valley is actually a glacial spillway that's carved by the meltwater. But a retreating glacier will also carve other landscapes or landforms such as eskers, drumlins. It'll form glacial lakes and then also kettle lakes.
That's pretty neat.
That's pretty neat. And then, of course, this is this photo from the beginning is a beautiful view of the town of Lebret in the Qu'Appelle Valley. Because of the scale of many glacial landforms, it's much more easily viewed from the air. So next time you're on an airplane, whenever that might be, make sure you look out the window and try to spot other glacial landforms. So this is a photo out the window of an airplane where you can see a part of the Capel Valley. So that's, again, a glacial spillway. And then in the background, these farmers' fields are occupying the lake bottom, or the former lake bottom of Glacial Lake Regina. And then these circular shallow lakes are what's called kettle lakes. So they form when blocks of ice calve from a retreating glacier and get deposited into the outwash plain. You might also know these lakes as kettle potholes. And again, another photo of the Capel Valley, and then in the background, it's studded with prairie potholes.
So as we continue our very long drive north, we're going to stop at Fort Alicorn. And the geological significance of Fort Alicorn is that there's something called a kimberlite pipe there. So a kimberlite is a volcanic rock that explodes or erupts down from deep within the Earth's surface in the mantle. And when the heat and pressure builds up there, and it essentially blows up like a steam pipe right up to the surface of the Earth. Currently, there is exploration being done at Fort Alicorn, and so we've got a very large drill rig, or it's actually a trenching machine that's trenching down up to 250 meters, I believe, through the superficial geology until you hit the kimberlite pipe. Now, the reason that kimberlite pipe is worth exploring for economic reasons is because they are host to diamonds. So diamonds are formed under extremely high pressures and temperatures down at the very base of our continent. And so the only way that you can get these diamonds that are formed so deep up to the surface where we're able to extract them is through kimberlite. So as the kimberlite erupts from the mantle, and it picks up the diamonds from the bottom of the continent and brings them up to surface and deposits them at the top of the kimberlite pipe. And the reason why diamonds are so valuable is they are the hardest known natural substance. They are very chemically resistant. They have the highest thermal conductivity, and of course, they are very pretty and shiny. So yes, they are a favorite gemstone for jewelers everywhere, but they also have a lot of industrial uses, such as abrasives and saw blades and drill bits. And for all the geologists in the crowd, a very important industrial use for diamonds is, of course, diamond drill bits that are used to drill into the rock. There's a number of other uses for diamonds, including some particularly niche ones that I find pretty fascinating, such as uses in high-quality speakers and heat sinks for microelectronics, which might be something we see a lot more of in the future. So we'll drive north for another couple hours until we hit Larange. And if you look over at the map, you can see that at Larange, our rock types change. So the rocks that we see north of Larange are called Precambrian rocks, aptly named because they are all rocks that are older than the Cambrian period or time period. So the rocks that you see in the map here that are brown, pink, and red, those are mostly igneous and metamorphic rocks. The large yellow rock that you see in the middle is sedimentary, and Savietta will touch on that later on. So the rocks formed, the Precambrian rocks formed in northern Saskatchewan took almost half the Earth's history to form. They range from approximately 1.6 to 3.6 billion years, with a few scattered younger intrusions. The flat-lying sediments that are found in the southern part of the province that are deposited on top of our Precambrian rocks, they were formed during the Cambrian and later time periods during when most of North America was covered with an interior seaway. So a big sea like this, what happens is many sediments and evaporate deposits are then deposited at the bottom of the seaway or deposited when it dries up. And that's what forms the many, many stratigraphy layers that lay on top of the Precambrian geology. And I included some pretty neat artistic representations of what life might have looked like if we were in Saskatchewan about 500 million years ago. So as I mentioned, the flatline sedimentary rocks that cover the southern part of the province, they formed within the last approximately 500 million years. So most of them were deposited at the bottom of the interior seaway, and then after the seaway dried up, there's also glacial deposits, and of course the soils that are forming currently. And if you notice in the pie chart time period, all of these rocks that are up to 3.5 kilometers deep in some areas of the province took only about 1/8 of the entire history of the Earth to form, or less. So the neat thing about the contact between the Precambrian rocks and the Phanerozoic rocks to the south is that contact is called an unconformity. And that unconformity represents a very large gap in time. So I mentioned the rocks to the north are usually about 1.6 billion years or older, a few younger ones in there, and the rocks to the south are around 500 million years or younger. So this single contact or surface actually represents at minimum 500 million years gap in time, but usually more like 1 billion or more. So that's the significance of the unconformity. And from La Ronge, we can jump into a bush plane and fly over to CB Gold operation. So many of you have heard of CB Gold operation, I'm sure. It's currently Saskatchewan's only active gold mine. The CB mine was was working from 1991 to 2018, while the Santoy mine, it started in 2014 and is currently, well, I don't know about currently, but has a bright future of gold production. CB had record gold production in 2019 with over 112,000 ounces produced. So there's a view of what the CB gold mine would look like underground. So this is a conventional mine that's dug underneath the surface of the earth. The gold is actually produced into what's called gold to ore bars right on site. So these are not quite pure gold bars that are then shipped in this fashion to get further refined at a third party. And as we all know, gold is extremely valuable. I think somewhere around $1,700 US per ounce right now. And the reason why gold is so valuable is that it's an excellent conductor. It's very workable, it's soft, ductile, malleable, and it never corrodes. So yes, that makes it a favorite for jewelry, but it is also so valuable that it itself is used in bullion banking. And uses for things like electronics and computers I find particularly fascinating because of their excellent ability to conduct, and it's the fact that it never corrodes. Gold is perfect for switchboards. So everyone who has their electronics and their iPhones and their laptops all has gold in the switchboards there. It is, of course, used for awards, status symbols, decorations, and cool high-tech things like satellite components and telescopes.
All right, so we're going to get back on the road and keep driving north. So as we drive past the community of South End, we're next to the second largest lake in Saskatchewan, Reindeer Lake. So this is a false color Landsat image, so it's a satellite image, where you can see the southern end of Reindeer Lake. And you'll notice that there's a highly circular body of water, Deep Bay. So Deep Bay is about 13 kilometers across and 220 meters deep. And of course, it's called Deep Bay because it is the deepest body of water in Saskatchewan. So Deep Bay formed from a meteorite impact 99 million years ago. So it's Deep Bay is also known for its good fishing, and according to legends, there's a monster that lives in Deep Bay that ate reindeer when they fell through the ice. Cool. Anyway, Deep Bay isn't the only meteorite impact structure in the province, so we won't show you any more now, but you can definitely find more on GeoExplore. Okay, so off we go again. We'll drive northward to Stony Rapids. So on this map, you'll see that we just drove past or through this yellow oval, which is a geological unit that symbolizes the Athabasca Basin. So you might have heard of this geological region before because it is where all the uranium deposits are mined in the province. So the sedimentary rocks that form the Athabasca Basin are up to, or are around 1.6 billion years old. Although that seems like it's really old, it's actually much younger than the rest of the Precambrian Shield, which is, as Sam mentioned, this in the northern half of the province, so all the pinks and orange on the map here. So yeah, now that we're at Stony Rapids, or we'll switch gears. But before we do that, I'll just point out that this image from near Stony Rapids shows these vibrant pink flowering plants, which are fireweeds. So these plants are native to this ecoregion, and this is an edible plant that thrives in areas that have been recently burned by a forest fire. So unique flora. Okay, so from Stony Rapids, we just took a bush plane to Uranium City. But before we step much further, we're just going to look on the ground and see another unconformity. So remember how back in Larange, we crossed a boundary representing rocks of very different ages? Well, here is another example of an unconformity. So on the left, we have Archean metamorphic rocks, which are really, really old, but then they are sitting adjacent to Athabasca Basin rocks, which are sedimentary rocks that are 600 million years younger. So although originally these the sedimentary rocks would have been deposited right on top of the metamorphic rocks, they now appear to be sitting side by side because of various geological processes like weathering and erosion and the shifting and rearranging of ancient continents over billions of years. So now it appears like it's next to each other, but it would have been deposited on top of each other. Okay, so now let's check out Uranium City. So as the name suggests, this is a small northern settlement that was once a hub for historical mining operations. So this photo here is a photo of a rock, uranium-bearing rock. So the yellow staining here you see on the rock is a secondary uranium oxide mineral. So today, much of the uranium operations in the province are focused in the eastern Athabasca Basin, where uranium ore is extracted from underground mines. Now, in these mines, there's mine engineering and design is done such that there's remotely controlled mining systems to ensure the safety of workers and reduces exposure to radioactive hazards. So uranium is processed into yellow cake, which is a form of uranium concentrate powder. It's not actually always yellow, but these are shipped in barrels to nuclear reactors, where it then gets processed further into fuel rods for nuclear energy production. The uranium in yellow cake is over 99% uranium-238, which is a stable isotope of uranium, meaning it has very low radioactivity. So yellow cake is effectively as radioactive as a bunch of bananas, which isn't very radioactive. How neat is that?
That's pretty neat.
Yep. All right, from Uranium City, we're going to get on a float plane at the local dock and fly across Lake Athabasca. So when you're on the plane, make sure you have a look outside, and you'll notice these sandy patches. Hey, that's beginning to look like a desert in Saskatchewan. Who knew? So these are sand dunes, sand dunes of the Athabasca Sand Dune Provincial Park. So these are one of the most northerly active sand dune formations in the world. These sand dunes formed at the end or near the end of the last glacial period, so that's about 8,000 years ago. The dunes are alive in that they are actively shifting, mostly affected by the winds. And you can notice in the previous photo, actually, you'll see that there's ripple marks, much like what you see at the beach. And yeah, so these dunes are 400 to 1,500 meters long, and their maximum height is about 30 meters. So as I mentioned, this region is part of the Athabasca Sand Dunes Provincial Wilderness Park, and this was created to protect this unique land feature and its associated ecosystem, which includes endemic plant species like the felt leaf willow and Flocos tansy. So you can visit these sand dunes by taking the path that we just took, which was really long, or you can even visit via canoe trip from Carswell Lake. All right, so this is as far as we can take you today on this virtual road trip. We hope you enjoyed seeing the diverse sites across the province. So yeah, we'll hand it back to Kate now, and she'll give you more information about how to keep exploring on your own. Thank you.
All right, thanks very much, guys, for that great tour. So we'll pause here and see. Ralph has been tracking the chats to see if there's any questions about the presentation so far.
No, Kate, actually, there hasn't been any questions, although there's one there right now, but we'll deal with that later. So no, you just go ahead with the tour.
All right, so we are going to go back now and have a little bit of a live demo of the website itself. So I'll just show you kind of how to navigate and what types of things you'll see and how it works. So again, when you first get to the website, you'll be on the welcome page. And I'm going to click on the map. So this takes you to a page that shows the entire map with all of the locations on it. So you'll see this looks very similar to what the paper map looked like, if you're familiar with that. So each one of the numbered dots is one of the sites that we have on there. So for now, we've just got pretty much the same sites that were on the original map. So I'm going to click on one. So when you click on a site, a little box pops up like this, and it tells you what you would see at that site. And it also tells you, if you click on the little arrow here at the top, it tells you about some of the map units in the area. So as it goes through the map units, it highlights that unit with a bright blue outline. And so you can see there are a number of different units at this location. So from this site, from this page on the website, you can go to any area that you like and click on the various spots. But you can also go to some of these other tabs for other information. So the Geo 101 tab has some basic geological information, basic concepts that you would need to help you understand some of the sites that you're going to see. So the Sask Geology page gives you a very quick overview of the high-level geology of the province. So it explains the unconformity concept and shows you where the unconformity is between the edge of the Canadian Shield and the sedimentary basin to the south. And there's a page that explains the basics of the rock cycle, and another one that explains plate tectonics. And as Sam and Sveta mentioned, there are a number of meteorite impacts in the province. So when you click on one of these pages here that's related to some of the sites, you'll notice that you've got a slightly different version of the map that's actually highlighting where the sites are that are related to that subject. So these pins here represent the meteorite impact sites in Saskatchewan. So you can see there that there are 5. And this is how the story map concept works. So as you scroll down through the story on the left-hand side, it moves you around the map on the right-hand side to show you what part of the story you're looking at. So I'm going to scroll now down through the story on the left-hand side about meteorite impacts and so on. And as we get to site-specific information, the map automatically zooms in to show you that site. So this is the Carswell meteorite impact structure here, which is actually in the Athabasca Basin. And so it tells you a little bit about that feature, and it shows you a picture of it there. And I'm scrolling some more. And now we're at the Gow Lake impact structure here. So again, the map has moved and shifted over to show you where that is. So that's the general concept of how the story map works. So if we now go up and take a look at, say, the sedimentary basins here. So again, as you scroll down through the story part on the left, it's going to move around and show you the different features that we're talking about. So let's just show that. So now we're going to the Athabasca Basin, which is again highlighted in blue here. We also have information on fossils, the Ice Age, and I'll click quickly on our resources. So again, some of the main tabs have sub-tabs and some of them don't. So if it has sub-tabs, they show up along here, and you can click on those and find out more information about particular types of resources. So we have one sub-tab for minerals and mines, one for oil, gas, and coal, one for soils, and one for kind of a variety of others that don't fit into any of these particular categories. So there's lots to see and lots to explore here. It's not completely finished yet. We're hoping that we'll have most of the currently planned content up there by the end of June. We're working hard to review everything and get it up there as quickly as we can. But we're hoping that this will always be kind of a living site that we'll be adding to and updating things on. And so that's one way that that you folks can get involved if you're ever out and about exploring the province and you have some good pictures of interesting geological features. We'd love for you to share them with us. We don't currently have a way to do that directly through the website. We may be able to do that at some point, but in the meantime, if you have something you'd like to share with us that we could add to this website, you can email the Saskatchewan Geological Society, and you can find the email address on our website. And what we would need is a high quality image that you can give us permission to use. We need the GPS coordinates and a brief description of what the site is about. So we hope that you will all go out and do some geo-exploring over the summer. You may not be able to go traveling outside of the province or very far from home during the current situation, but I'm sure you can find some interesting geological sites not too far from where you live, and we really hope that you will share them with us. So I won't say any more, I think, at this point. I will see if we have any questions now.
Yeah, we did have a couple of questions. So one of them was if there's any data that can be downloaded from the site, and the answer to that is no, not really. You can't download geochem data or anything like that. For that, you'd want to go to the Geological Survey's GeoAtlas, and I can share the link to that later in the chat. There's also a question if you can zoom in, and I think Kate showed that you can zoom into the hotkeys as the question asked, and as you zoom in, they will separate. So there's some overlapping points in Regina, for example, and just as a side note, in Regina, we're planning to put on a lot of the buildings that have rock on the side of the building, like building stone materials, and we'll have lots of points in Regina. So, and as you zoom in, you would be able to see that these points separate, and Kate's kind of demonstrating that as we go. Those are all the questions that I see for the moment. There was also earlier a question about whether this video will be made available, and maybe Pam, can you speak to that potentially?
Hi, Ralph. Yeah, we will make sure this video is available and the presentations as well, and we'll have them on the Sask Mining website at saskmining.ca. But I think the presentations as well as the GeoExplore are also on the Saskatchewan Geological Society homepage at SGS Home. So if Ralph will put up the link to the GeoAtlas where you can download different layers, and I will also put in the chat the addresses where you can go. We won't be emailing out people links just because we don't necessarily have everybody's email. So we'll get you to look to these various email sites that we're going to give you.
Okay, yeah, that's. I think that's it from me, Pam. So I don't think there's any further questions. So I would just like to thank everybody for joining. The turnout was tremendous. I think I saw up to 150 people there at times. And since we still have a few minutes, I thought maybe I'll just take the time to thank some of the people who were involved to make this project possible. So I'll just quickly read off their names. It's Kevin Ansdell from the University of Saskatchewan, Emily Bamforth from the Saskatchewan Museum, Janice Dale from the University of Regina, Michelle Hansen from the Geological Survey, Kim Kreis, who used to work for the survey and is now an independent consultant, Thomas Love with the survey, Hossein Narimani, he's a graduate student at the U of R, and he's been the one who's uploaded all the content essentially. Pam Schwan with the SMA, who you've met, and Bill Sliman, who's also retired from the survey. Yeah, with that, I'd like to thank everybody, and I'll just turn it over to Pam and or Kate. I guess Pam first.
Thanks again, Ralph. And yes, I'm just going to thank both Kate, Ralph, Sam, and Saviata for a great presentation today. It was highly scenic and interesting, and I'm sure everybody wants to get out on the road and go geo-explore. I'd also like to really thank Kate and Ralph for being the drivers for their vision behind taking the Geological Highway Map digital, and also the major sponsors, APEGS and the Saskatchewan Geological Society. And I know this resource will be used by a lot of educators across the province, and we're really delighted to have been able to have a small part in that through the Saskatchewan Mining Association. So Kate, before I give a final thank you, did you have anything you also wanted to add?
No, I don't think so. I'll just maybe add that on the About Us page, you can find the names of all the people that contributed. I know they were just mentioned, but all the various roles that the various organizations and people have played in this is on there under About Us. So yeah, and you can always contact the Society too if you have any more questions about the site. So thank you everybody for coming today.
Okay, I think I believe that's it then. So thank you everybody for joining us, and we also invite you to join. We have 2 more presentations left during Mining Week. They're all virtual. One is on commodities tomorrow afternoon on uranium and potash, and the other is looking at women entrepreneurs in Saskatchewan, and that will be hosted by Women in Mining, Women in Nuclear, with a presentation by WESC. So have a great and safe Saskatchewan Mining Week, and everybody just go geo-explore Saskatchewan. Thanks for joining us.